Welcome back to CrowdSec Mastery. Lesson 04 was the theory, how parsers extract fields, how leaky buckets actually work under the hood. Lesson 05 is where you stop reading and start writing. By the end of this lesson, you'll have built an Nginx 401 brute force detector from a blank YAML file and watched it fire on real log lines. We'll cover the 3 scenario types, the CEL filter language, the groupby and distinct combo that trips everyone up, and 5 gotchas that'll save you hours of debugging. Before we touch any YAML, you need to know that leaky isn't your only option. CrowdSec gives you 3 scenario types: leaky, which fills a bucket over time and overflows; trigger, which fires immediately on a single matching event, perfect for known CVE exploits or bad signatures; and counter, which tallies unique values inside a fixed window, ideal for catching a scanner hitting 50 different URLs from one IP. When in doubt, reach for leaky. About 90% of real detections boil down to too many of X within Y's. Now, every scenario you write has a filter field, and that filter is written in CEL, Google's common expression language. Think of it as a stripped-down JavaScript, comparisons, Boolean logic, a handful of string helpers. The left side here is your operator toolkit: equality and/or not, the in operator for set membership, matches for rejects, and the Elvis operator for safe defaults. On the right, the string helpers you'll actually reach for: starts with, contains, lower, IP in range for CIDR checks, and len. Memorize these. They cover 95% of every filter you'll ever write. With your filter logic in hand, the next decision is how to split events into buckets. And that's where groupby and distinct trip up almost everyone. Groupby creates one bucket per unique value of an expression, almost always source IP. So each attacker gets their own counter instead of all traffic piling into one. Distinct, which only works in counter-type scenarios, counts unique values inside that bucket, like 21 different URLs from the same IP, classic scanner behavior. Hold on to this mental model. Groupby is WHO, distinct is what? Get that backwards and you'll either ban the entire internet or nobody at all. So here's your full field reference. Bookmark this slide because you'll come back to it. The 3 in red are non-negotiable: type, name, and filter. The orange block, groupby, capacity, leak speed, is what turns a filter into a leaky bucket or counter. Distinct is counter only. Black hole and labels you'll add to almost everything in practice, and data lists are for when you start pulling in country or ASN lookups. Required, common, advanced, that's the mental hierarchy. All right, theory's done. Let's build something real. The goal: catch any IP that racks up 5 or more 401s on Nginx in 30 seconds, which is the textbook signature of a basic auth brute force. We group by source IP so each attacker gets their own bucket. Capacity 5 means the 6th 401 overflows, leak speed 30 seconds keeps it tight, and the 1-minute black hole stops us refiring on the same IP. Drop this in, etc. CrowdSec scenarios, reload the daemon, and cscli scenarios list should show it enabled. But writing the scenario is only half the job. You need proof it fires on attacks and stays quiet on normal traffic. The trick is cscli explain with the F flag. Feed it a log file and it shows you every pour and every overflow, scenario by scenario. So we fabricate 10 401s from a single IP, pipe the log through explain, and watch the bucket fill. 1, 2, 3, 4, 5, then overflow with a decision queued for the local API. One last cscli decisions list confirms the ban is live. That's your full feedback loop. Now that you've seen a bucket fire end to end, let's slow down and name the 4 states it actually moves through. Empty. No bucket exists yet for that groupby value. The first matching event spawns 1. Pouring. Events accumulate while leak speed drains in parallel, and you'll see pour lines in the log with the current bucket level. Overflow. Capacity +1 is hit. One decision gets posted to Lappy, and the log shouts overflow. Then black hole. The bucket cools down. further matches are silently dropped and nothing hits your logs. Read CrowdSec.log with this state machine in mind, and debugging stops being guesswork. With the state machine clear in your head, here are the 5 mistakes that will bite you anyway. 1. Forget groupby and every IP shares one bucket. Random people get banned together. 2. Silent filter typo, EVT parsed versus EVT meta, 0 pores forever. 3. Capacity is off by 1. Set 4 to fire on the 5th event. 4. Leak speed tuned for your test bursts is too tight for a real attacker spreading over minutes. And 5. If black hole is shorter than ban time, the same IP refires every cycle. Recognize the symptom, apply the fix. Once your scenario survives those traps and catches something real, think about pushing it upstream. The workflow is standard GitHub. Fork, crowd security, Chacher hub, branch as scenarios your name, and drop your YAML under scenarios. Then add a tests folder with sample logs, write a readme explaining what it detects, and run the validation suite locally before opening the PR. One rule, strip your personal namespace before submitting. Once merged, anyone can pull it with cscli scenarios install crowd security your scenario. So let's pull it all together. 6 things you now own. The 3 scenario types and when to pick each, CEL as your filter language, the difference between groupby for who and distinct for what, the full 10-field anatomy with the first 3 required, the pore overflow black hole lifecycle you can trace in the logs, and the 5 gotchas that bite everyone the first time. That's the entire pattern, and it scales from Nginx to Postgres, Kafka, Redis, or whatever you're protecting next. And that's lesson 05 in the bag. You've got 3 scenario types under your belt, CEL syntax that actually makes sense, a working Nginx 401BF shipped to disk, and a clear mental model of the pore overflow lifecycle. Next up, lesson 06, where those overflows become decisions, hit the lappy database, and get routed to bouncers through profiles. YAML. That's where detection turns into action. See you there.